We have this situation in some molecules of having more than one way to put in the shared pairs. That's a situation called resonance. Let's think some more about this. We'll draw the Lewis structure of ozone, O3. Similar to what we saw in the examples in the previous section of this module, there should be 3 shared pairs. There should be one double bond and one single bond. We can choose to draw the double bond to the left oxygen or the double bond to the right oxygen. We would say that these 2 Lewis structures are resonance structures. Resonance is present when there is more than one way to distribute the electron pairs in a Lewis structure without moving the atoms. In the case of ozone, we have essentially converted a shared pair into a lone pair and a lone pair into a shared pair. Earlier we introduced the idea of bond order. When there is more than one way to draw a structure, that complicates things. Remember that every bond has a bond order. Let's take a look at the bond between the central oxygen and the left-hand oxygen. In the first structure, this is a double bond with a bond order of 2. In the second structure, this left bond is single with a bond order of 1. So how are we to report the bond order? Here we would take the average. The left OO bond has a bond order of 1.5. Using the same logic, the right OO bond also has a bond order of 1.5. Notice these add up to 3, which is the number of shared pairs. Fractional bond orders can exist if there is resonance. Some students, when drawing the Lewis structure, will draw this. All 3 of these structures show 3 shared pairs, 18 electrons total, and satisfy the octet rule. So, what's wrong with the triangular structure? That brings us to a more general question. How can we judge the quality of the Lewis structures that we draw? We'll deal with that next.